Welcome to this Maths Made Easy video on parametric equations. To start with, let's take a look at skill 1 on parametric equations. Now you need to understand what parametric equations mean and how to plot graphs from them. So for example, if we're asked to sketch the graph of x equals t minus 1 and y equals t squared, okay, how would we do this? Well, what we do here is we create a table of points. And let's say we take our values here from t equals minus 4 up to 4. What we do then is we find the respective x and y values for each value of t. And if we take that example from t equals minus 4 to 4, we obtain something that looks like this. Notice here, when t equals minus 4, x is equal to minus 4 minus 1, giving us minus 5, and y is equal to minus 4 squared, which is 16. When t is 0, that's 0 minus 1, giving us minus 1, y is equal to 0 squared, which would give us 0. Okay, so clearly we just need to repeat that for all values. But once you do that, you should find you get these x and y values. And all we need to do now is plot these points on a graph. And if you do this correctly, you should get something that looks like this. Notice we have minus 5, 16, minus 4, 9, minus 3, 4, minus 2, 1, so on and so on. Okay, so that gives us the graph there that we require. Now you should also be able to answer questions such as what is the value of y when t equals 4 and what value of t corresponds to y equals 1. All questions of this form can be solved by substituting in the right values into the parametric equation. So for example, for the graph x equals t minus 1 and y equals t squared, find the value of y when x equals 5. So in that case, x is equal to t minus 1. So if we're saying x equals 5, we should replace x here with 5. So 5 is equal to t minus 1. And here now we just solve for t. So therefore, t is equal to 6. And what we do now is we take this value of t here and substitute it into our equation for y. So therefore, y is equal to t squared. So therefore, y is equal to 6 squared, which is equal to 36. Okay. So that gives us everything we need there for skill 1 on parametric equations. Moving on to skill 2 now, which is taking a look at parametric equations of circles. Now, while t is the most common parameter, some parametric equations use trigonometric functions, and as a result, use the parameter theta. The parametric equation of a circle with radius r and centre AB is given by x equals r cos theta. So r cos theta plus a, and y is equal to r sin theta plus b. So for example, using this picture here, we have a circle with centre 3, 4 and radius 5. So its Cartesian equation is x minus 3l squared plus y minus 4l squared, and that's equal to r squared, which is 25. In this case, it would have parametric equation x equals 5 cos theta, so 5 cos theta plus 3, and y is equal to 5 sin theta plus 4 there. Okay, and we just note here, if the radius were different in the x equation and the y equation, then we would have an ellipse. Okay, so that gives us everything we need there for skill 2 on parametric equations of circles. Moving on to skill 3 now, which is taking a look at intersections of graphs and parametric equations. So to find the intersection of a parametric equation and Cartesian equation on a graph, we substitute in the values for t, for x and y into the Cartesian equation and then solve for t. We then find the x and y values corresponding to that value of t. So for example here, if we want to find where the graph x equals 3t plus 4, so x equals 3t plus 4, and y equals 2t squared, so 2t squared intersects with the line y equals x plus 1. Okay, so y equals x plus 1. Well, if we start by considering y equals x plus 1, well, we know y is equal to 2t squared and x is equal to 3t plus 4. So in that case, using this, y equals x plus 1 Well, we can replace y here with 2t squared and x with 3t plus 4. So we've got 3t plus 4 plus another 1, that gives us 3t plus 5 there. Okay? And because I've now got a quadratic equation, I'm going to rewrite this now, or rearrange this such that it's equal to 0. And then we can simply solve for t. So we get 2t squared minus 3t minus 5 equals 0. And here, as we have a quadratic equation, the first thing we should always check is whether this factorizes. And here we do find indeed that this factorizes. What we obtain is 2t minus 5 and t plus 1. Okay, and this is equal to 0. And that gives us two solutions now for t. What we have here is t is equal to 5 over 2. Or we have t equals minus 1. Now, what we want to do now is find the coordinates here, so we consider our x and y equations. So x is equal to 3t plus 4. So here, let's consider 5 over 2 first. That's 3 lots of 5 over 2 plus 4. And if we evaluate that here, we get 23 over 2. Okay? And when t is equal to minus 1, then we obtain for x here 3 lots of minus 1 plus 4 there. Okay? And 3 lots of minus 1 is minus 3 plus the 4 gives us 1. Okay? So we've got two values for x then. Now we just need the two values for y. So here, using the fact that y is equal to x plus 1, therefore y is equal to 23 over 2. So 23 over 2 plus 1. So that would give us 23 over 2 plus 2 over 2, giving us 25 over 2. Or we also have here y equals, so in this case x plus 1, if x is 1, that's simply 1 plus 1 there. And that would give us 2 there. Okay? And that gives us our solution there to that example. So that gives us everything we need there for skill 3 on intersections of graphs and parametric equations. Moving on to skill 4 now, which is taking a look at finding the Cartesian equation. So it's possible to get back to the Cartesian equation of a graph from its parametric form. The way to do this is to rearrange the equation of 1 of x or y into the format t equals f of x or t equals f of y. So this is t equals f of x or t equals f of y. Okay, and then we substitute in this expression for t into the other equation. So for example here, if we wanted to find the Cartesian equation of y equals t squared and x equals t plus 5. Okay, so x equals t plus 5. Well, if we take x equals t plus 5, so x equals t plus 5, we rearrange this here, we're going to get t equals x minus 5. Okay, so rearranging this to be t equals. Therefore, we know y is equal to t squared, so we just substitute in t here. What we can see then is y is equal to t squared, which is equal to x minus 5 squared. And in that case then, we just expand this. That would be what we need there. Or we could just leave it in this form here. That would be absolutely fine as well. Okay, so that gives us everything we need there for skill 4 on finding the Cartesian equation. Moving on to skill 5 now, which is taking a look at using trig identities to find the Cartesian equation. Now, for parametric equations involving theta and trigonometric functions, it is often necessary to use trig identities to recover the Cartesian form. So for example here, if we want to find the Cartesian equation of x equals 1 plus cos theta, so 1 plus cos theta, and y is equal to cos of 2 theta, how would we do this? Well here, let's take x equals 1 plus cos theta, so x is equal to 1 plus cos theta. Well, I start by rearranging to get this to be equal to cos theta. So I subtract 1 off both sides of this equation. We obtain cos theta is equal to x minus 1. We also have y equals cos of 2 theta. Okay, so y is equal to cos of 2 theta. And we know our identity here for cos of 2 theta, which we can write as 2 cos squared theta minus 1. Now if we know cos theta is x minus 1, that means we can write this as 2 lots of x minus 1 squared, 2 lots of x minus 1 squared minus 1. And here we can expand these double brackets, so we get 2 lots of x squared minus 2x plus 1. Don't forget our minus 1 here that we originally had. Now if we expand this bracket by 2, we get 2x squared minus 4x plus 2 minus 1. And if we simplify here, we get 2x squared minus 4x plus 1 there. Okay, so that gives us everything we need there for skill 5 on using trig identities to find the Cartesian equation. And finally, let's take a look then at skill 6, which is modelling with parametric equations. Now, parametric equations can be used to model real-life situations. However, this can place restrictions on the parameter because some scenarios are not possible in real life. So what situations might lead to this? Well, the equations could model for a parameter where only some x and y values make sense, for example, positive values. Restrictions could exist to avoid repeating values of x and y, such as limiting theta to be between, for example, 0 and 2 pi. So obviously that's when we're using our trigonometric functions. And another restriction that might be necessary is to avoid dividing by 0. Okay? For example, if we had x equals 1 over t minus 1, then we must say that t cannot be equal to 1 there. Okay, because otherwise, if t was possible to be equal to 1, that would lead to be a division by 0 there. Now, the values of the parameter that are allowed are collectively called the domain of the parameter. So let's take a look at an example then. So if we just clear what we've got on the screen so far. So for this example here, let's say a tennis ball is thrown into the air. Its horizontal distance from the point of throwing is x equals 25t. Okay, so x equals 25t. And its vertical distance from the point of throwing is y equals 9t minus t squared. All we want to do here is find its vertical distance when it has travelled 50 metres horizontally. And we can approach this problem in the same way we would approach a problem that is not modelling a real thing. So here x is equal to 25t. Okay, so in that case we set this equal to 50. So 25t is equal to 50 because remember this x here represents the horizontal distance. Okay, so 25t is equal to 50, so that means t is equal to 50 divided by 25, which is 2. Okay, now we know y is equal to 9t minus t squared, and all I simply do here is substitute my value of t in. So therefore y is equal to 9 times 2 minus 2 squared here. Okay, so that gives me 18 minus 4, which gives us 14. And remember the units here, in this case this would be meters. Okay, so 14 meters there. So that gives us everything we need there for skill 6 on modelling with parametric equations. And that concludes this Maths Made Easy video on parametric equations.